Thanks, Bob, and thanks for the invitation to speak here today from the organisers. What I'm going to talk about today is largely this project we've been working on for the last 18 months, which is scoping opportunities for future investment, which has been looking at what might be achievable, without getting too futuristic there, but what might be achievable in terms of productivity gains. Now, in that, I'm going to try to integrate some of the messages in a couple of days. So it's not a summary of that, but just trying to integrate it. And the project team down the bottom there was a cast of many, Lee Hunt and Cam McDonald, who was critical to a lot of the modelling work, Lindsay Bell, Robin Cowley, Ian Watson, John McIver and Neil McLeod, who is sitting up the front here, did a lot of the economics work. So just to set the scene, and this picks up a little Peter Barnard yesterday in his opening talk, but just that, as we all know, profitability in the industry is pretty low for many producers, and the work done in the situation analysis report, Terry McCosker and Phil Holmes, a few years ago now, indicating that profitability near zero at that stage for the last 6 years or something, but I think it's probably up in the area now. And that's putting huge financial pressure on producers, and we're seeing that out in the press and in various producer forums that are held around the country, Northern Australia these days. And of course we all know that costs and debts are increasing. This is work from ABARES from Trish Gleeson, just showing how in the northern live export region, how it's been increasing over the last decade or so, with the average debt load there now somewhere around $1.4 million, which is putting incredible stress on producers. Of this is the decline in prices, so you've got those costs and debt going up, but an issue of prices declining and herd productivity somewhat stable. If we just follow the brownish dots there, are they brown or are they green? I'm colourblind, so anyway, they're one of the two. The round dots, I know that. You'll see that in the period from the 1970s through to 1990s, and the productivity here, the left-hand, the y-axis at the left-hand side, is expressed in the kilograms of beef relative to the total herd. So these are numbers, not the whole of Northern Australia, total Queensland numbers. So they're all the kilograms of beef that have come off through meatworks and through live export relative to the total herd numbers. Pretty much doubled over that period, so of the 1970s through to the 1990s. So incredible increase in productivity, but it's flatlined somewhat in the last or so. The climatic events of the first half of this century probably contributed to some of that. Is down in the last, or continuing on even over the last few years, which have been better in terms of seasonal conditions up until this last year at least. And then if we look at prices in the and these are being corrected to 2012, so that we're comparing apples with apples, taking inflation into account over the last 40 years. And so prices are slowly eroding since 2004 or so, and the red triangles there at the end are the ABARES outlook for the next 4 years for beef prices, so continuing downwards. The other aspect of this is total factor productivity. Again, work from ABARES, and I won't spend too on this, other than it's a ratio of the input the output that you get out of the system in terms of the pretty much divided by the input factors that go into it, land and labour, sorts of things. It's a bit of a black box calculation, but it's a measure of overall productivity, and it's a index of 100, and it's gone up over the years. You see some ups and downs there, but particularly in the last 10 or 15 years, most of that increase, or most of the increase in the total factor productivity hasn't been on the output side, it's been on the input side. So reducing inputs into the production system, efficiencies there in the inputs. It doesn't mean that we know the cost per unit out rapidly, but reducing labour, economies of scale, all reducing that. How far can you go with that is a question. So the challenge is looking ahead. So if you assume costs are going to continue to increase at roughly 2% per annum, costs will be 40 to 50% higher, coupled with the likely ongoing decline in terms of trade that we've seen over the last 40 years. So will small gains in productivity coupled with further gains in cost efficiency, there's been a lot achieved in the industry, but will that be enough? I suspect that if we can't increase productivity, then our enterprises, the producer enterprises, are going to get a bit wobbly, possibly fall over. Now, we can really focus some efforts on some individual technologies, some smart new individual technologies that will make our little enterprise somewhat more comfortable for a while. But if you're not concentrating on other bits, you mightn't be able to pay the electricity bills and you'll fall over again. So we want to end up with something where we have, which are fully productive and employing a whole lot of new innovative technologies to the outcome we're after. So it's with that in mind we set about the scoping study, and this figure here, the left hand is just a conceptual representation of productive potential, up as shown in the earlier graphs, and hopefully we can continue for it to go up, even though there's been a stagnation in productivity just recently. And there are two ways of how we can get up to that productive potential. One where we've got current industry, the best producers being up near the productive potential, but a lot of industry is productive potential. So through best management practices, lifting it up to that line, and there's a lot of work going on in best management. The other is to look forward and say, well, how can we look for opportunities to push up that line? And so that's where we've focused most of our effort, although there are elements of the best management practice that come into some of the scenarios that we've. So where can on-farm productivity gains be made? Well, one is it's increasing herd number, but not just through whacking more animals with all the resource implications that has, but some where you have, particularly in the more extensive, where you've got opportunities through development to, achieve more even utilisation and exploit parts of the properties that aren't being effectively used. You can increase weaning rates, you can increase growth rates, and you can reduce mortality rates. So there's a small number of levers there. And of course, in terms of overall productivity, you can reduce costs. And we heard before afternoon tea from Dave Swain around some of the precision life. We didn't look specifically at that in terms of cost reduction because a lot of that work is ongoing, and as Dave explained, that's still the next phase is to see what are the achieved with that. And of course, through infrastructure, you can, while you've got some upfront costs with that, you can reduce your operating costs per time. And the second point, we wanted, apart from looking at the productivity side, we wanted to make sure that in pursuing those gains, that you were keeping the resource base intact. So putting all that together, we've got this representation of a northern beast system where you've got factors of climate and environment and your location. That you can't change those, but they influence your type of operation and your herd structure. Beneath that, you have a whole lot of management and innovation factors there. This box over here, which feeds into the system there to feed production. Obviously, and what you do in management has a strong influence on cost of production, and that production and cost of production feeds through to profit. And there's an interaction between resource management and production, and I'll come on to how we represent that shortly, and that also feeds through to profit, particularly with some, if you're looking at things like, as Tom Davison explained before morning, there around some of the opportunities that might be through some methodologies in carbon farming. So in the how we're representing that within a modelling sort of approach, which we've taken, you've got to have some nutrients coming into the animals. So we represent that through supplements, forage crops. We use a cropping model called APSIM, and pasture, a grass model, and they all come together to create an energy and model. So we've tried to grow the animals basically from when they're born through to slaughter, or in some kind of energy and protein until they die in the paddock system. So you need that energy and protein. Of course, genetics is an important component, ultimately what you're trying to achieve in those key levers in that dark blue box beneath, in, come back there, right button, in reproduction, growth and mortality. And also herd management is a critical factor. So you've got herd management, genetics, energy and protein all feeding into reproduction, growth and mortality. Herd management through numbers of stock feeds into resource condition, and they all go into profit. And resource condition can have a feedback effect then onto what happens in the pasture system. So you get a feedback loop through there. So we've tried to represent that in our modelling approach. It's not perfect. No model is, and it was really a first attempt at trying to put together to explore some productivity options. It wasn't trying to perfectly capture in detail every component of the system, because we just can't do it. So there's assumptions and simplifications there. And I just wanted to reflect here of Ian Braithwaite's talk this morning, just before lunch. And if you look through that, it's a different representation, but basically Ian's got exactly the same sort of system there as I put in the previous diagram. But what he's highlighted here is once you get into the devil of the detail, there's a lot of individual factors at play here and lots of levers that can, and we couldn't, and it wasn't the intention to try to represent that in what we were attempting to do. So we looked at different scenarios, the baseline, looking at practice, based on some work from the Northern Grazing Systems project, which had concluded a couple of years beforehand, and then a range of development scenarios, productivity, and design in such a way that land condition was maintained. So we were running these in a way that we didn't flog the system, hopefully. 10 regions, based on the Northern Grazing System work that was done, the Pilbara, Kimberley, Central Australia, VRD, combination of Barkly, Northwest Queensland, and then a number of regions there through Queensland. We used benchmarking using CRC data and some property records, and I'd just like to acknowledge some others that provided. I sat down with Michael Lyons and Roger Landsberg there for a day or two, and they were very generous with their time. Roger provided some fantastic sort of records there that helped us sort of calibrate things. So we're indebted to not just them, but a range of other producers we interacted with along the way. Just in terms of that benchmarking side of things, again, what we heard during the last couple of days, Mike McGowan this morning with the project, is that resource now that's been developed from that project just provides an incredibly valuable set of data that we can use in some of these modelling approaches to relationships in there, for example, around that drive within the model around, say, reproduction, that are based on the cows relative to their reference weight, so that you can get a body condition score, and relationships to drive that. That Mike presented there today, and the team from Cash Cow will go a long way to improving those relationships within this sort of a. So moving on to the actual scenarios, so we wanted to look at things that weren't necessarily widely practiced now. So it was high input irrigated forages, so mosaic forage crops, where small areas of land are used for to feed cohorts of animals. So we took a simple approach of saying, particularly in some areas where you may not be able to grow animals, say to JAPOX, what difference would it make if you had these higher quality forage animals into that condition? We weren't constructing no abattoirs west of Townsville over in the Territory or the Kimberley Pilbara area at the moment, but we still factored that relevance of transport costs into our modelling, but assuming that you may have an abattoir closer by. So those come into things because you can get constrained and captured by the present, and so we look at what might be plausible. And of course, yesterday, Ian Watson specifically about mosaic cropping and used that sort of approach in providing some high input forage, whether it be forage sorghum or down into southern Queensland. We looked at oats down there. Genetic is going to be an important part. It is an important part of improving productivity of herds and will be into the future. We've tried to represent that in our modelling approach. We have relationships between body conception rates and we can use genetic gain, represent genetic gain by shifting those sorts of relationships and shifting the response curves. This morning from David Johnson, who suggested that we might be able to get a 10 to 14 unit increase in 10 years. So in our scenarios, we were not that. We've, in the modelling we used, and that can be altered fairly easy, with unit gain in weaning rate to represent genetic gain in the sort of foreseeable future. You can't achieve bigger gains through other means, for example, tropical composites, and we heard from Troy Setter yesterday on that, and the previous work from the CRC that showed you could get sort of 15% unit increase rate through using tropical composites. A major limitation to production in the north is energy. We focus a lot on protein as well, but energy is a major constraint, and it's been to crack in a practical way. And these are a graph from Stu McLennan, his talk yesterday. Just the gross margins from that production feeding of a high energy and protein diet with 3 or 4 kilos a day, Stu, I think, something like that, out in the paddock. But you can't make money out of it substituting in a way. So we need to look at are there other ways we can do that. One is the ability of the forages, whether that be through rumen modification, rumen bugs, or returning to or back to the future, breeding, pasture breeding. Can we breed higher digestibility varieties of, for example, buffel grass? So that's just a couple of examples there. And it was in this is a slide from Ian Braithwaite's talk again this morning, where he raised a couple of these issues of where you might improve things. The bottom 2 dot points there, ability of pastures, identifying elite genetics. Two of the scenarios we needed to look at in this sort of study. The next is low-cost and their persistence. A lot of work gone on in the last 30, 40 years on that, and there's been some noted successes. But across Northern Australia, the total area under legume pastures is still fairly small. And over the last couple of days, yesterday, we heard 3 talks that looked at, and there's some opportunities for this. Chris Gardner and talking about this. We also had Gavin Peck talking about legumes being the most promising long-term in the work he presented on sown grass rundown and legumes, and also Kendrick Cox in his presentation talking about maybe not, but a new beginning and the opportunities there. So we represented it in our approach, low-cost legume pastures, again based on some data of trying to get them established, representing about 10 to 20% of the pasture component. Another area is cheap protein. We know the benefits that protein supplements can provide, but the issue has always been just the cost-effective use of them. And there are opportunities. This is just a screenshot of the proceedings, but from a poster out here from Karen Harper and Dennis Poppy around our huge investment going in the energy sector, biofuel sector, on algae development. And of course, once you extract the oil from the algae, you're left with a high protein meal. And if that sort of technology scales up, is it going to be a cheap protein source? It's not at the moment, but will it be? And some of the research in Stu McLennan's paper there, where he talks about cottonseed meal. So we represented that in ML by saying, well, if you could develop a cheap protein source for $200 a tonne fed, what difference could that do in feeding not just to some growing animals, but through the herd? And managing land condition while increasing productivity. Peter O'Regan talked this morning on Biana and the importance that can have in looking after the country in terms of not just cattle productivity, but importantly the profitability. So it's important that in undertaking this sort of scoping sort of analysis that we took that into account. And it's not just on property; it's what's happening off. And Rebecca Bartley this morning also gave a fantastic presentation on that work that's going on there. So we want to keep the sediments in the producing grass for production. So I'm going to move on now and just give you a few slides on some of the results. And so these are the different scenarios that I talked about, with the baseline, the ruminant, irrigated forage, legume, breeder genetics, cheap protein. The other side of genetic gain, which I didn't mention just before, is also genetic gain in growth efficiency. So we've represented that by altering the efficiency with which is used in growth in our relationship. So you can represent that fairly effectively. And the last scenario there is what we've called combined scenarios. So looking at these individually, we took the ones that didn't involve a large capital investment. So the irrigated forage and the legume treatment, still they involve a large upfront capital expense. We took the other four scenarios, which are more associated with what you're doing within the immediate feeding or breeding. So the rumen modification, the breeder genetics, the cheap protein and the growth efficiency, targeting different elements of the animal system to see what you can achieve in terms of the combination of those. And that's that last figure there on the combined scenarios. So in terms of weaning rate, across all those regional herds, across every area, we had a weaning rate of 59%. And if you go across, say, I said we had a 5-unit increase in weaning rate, and that's represented there. We've gone from 59 to 64. But what you can see, though, through some of the other there, is that particularly with, say, rumen modification or the cheap protein, which is applied to the whole herd, is the flow-on effects of that reproduction. So by providing that, it's had its main effect through improving body condition of the cows. And as a consequence, weaning rates going up, in some cases quite significantly, up 66%, or in the combined scenario, it was 74% increase in weaning rate from putting all those things together. If we look at live weight gain of the growing animals within those herd, so the baseline was around 130 kilos. Of course, supplying irrigated forage, and we're using the irrigated forage, the sale animals, that we could get up over 200 kilograms of gain there. You go across the breeder genetics, we got no increase in live weight gain there, because all we were doing in representing that scenario is increasing the weaning rate. We're doing nothing else within the system. And again, if you go across to, you look at legumes, obviously push it up quite a bit based on a lot of work, and the model fairly well what we would expect from a legume in the system based on all the live weight gain data that's been collected over the years. With the cheap protein, if anything, we've underestimated the live weight gain there based on the work of Stu McLennan and Dennis Poppy. We're only getting something like a 200 gram per day benefit from that kilo or so of cottonseed meal, whereas I think most of Stu and Dennis's work will say day gain from that, so we may have underestimated that slightly. But again, a good benefit there once you go across to the combined scenarios. Turnoff, and this is represented as just total kilos of beef that have come off the property in tonnes per year per property, that we start to get to signs when you look at the baseline there of whatever it is, 800 and something, 850 or so tonnes. You go across to the combined scenarios there, up around 1,400. So you're getting something like increase in 50% increase in productivity. And for some of those other scenarios, 20 to 30%. So we are starting to shift the system quite a bit. Now, how does that translate into the economics? If you look at first of all, a gross margin per adult equivalent, some significant gains there, your minimum of $10 per AE going up to 40 or more dollars per AE when you go over to the combined scenarios. Now, as we go from this slide to the next one, you'll notice that the irrigated forage and look pretty good there in terms of gross margin per AE, but of course they don't include the capital costs associated with their development, and they require very significant capital costs. And so when you move on to look at profit, the legume ones and the scenarios come back a bit, but they're still, particularly the legume one, is still a very significant. And the one that, if you've been following these, is the rumen modification there. And all we were doing in that was representing decline. As the seasonal decline in digestibility of the forage occurs, and we've got a lot of NIRS data around that shows that, and typically you might go down to 40% as the base level in the middle of the dry season. We just slowed down that decline slightly and ended up with digestibility only being 2 units than the baseline. And it only takes a small change in that digestibility to make a huge increase in the production flowing right through to profit. I will just comment more on the irrigated forage one there, because there's only about a 40k or a 10% increase in profit, but capital investment, you're talking somewhere between $5,000 and $8,000 per hectare. So you're putting in 500 hectares of it, you're talking investments of many millions of dollars, and and your return on that capital investment then is somewhere in the order of 5 to 10%, which is pretty risky on that sort of investment, because of course the model assumes you don't have stuff ups around. Some of these bigger developments in the north have been not uncommon. So that's just some of the risk that needs to be looked at when you're examining these. So that just gives a snapshot of the scenarios. Thanks, Bob. And resource. So in terms of resource condition, so through all those scenarios, we maintained average sort of pasture utilisation rates at 20 to 25%. They only varied by a couple of units. The herd numbers were allowed to go higher in the legume scenario because we have more forage there. You're growing more through the introduction of the legume, so it's higher. The AEs could often be 15% greater, particularly in something like the combined scenario, without the herd up anywhere near 15%, because the animals are simply bigger. They're in better condition and they're bigger in the AEs, and you're getting much more of the animal consumption being used for gain rather than for maintenance, and that makes a big difference in terms of being able to actually increase without changing utilisation too much. But under a number of those scenarios, if we just let them go, training them, the numbers would go up just because of the increase in production in the system. So we had to actively wind back some of the breeder numbers to maintain land condition in setting for the 20 or 30 year runs that we did this over using historical climate sequences. In terms of methane, because as you increase, we're increasing quite significantly overall productivity of the herd, total meat was going up, which you could say is not a particularly good thing. But on the flip side, the intensity of methane production was improving by 10 to 20%. So you could look at it differently. You could say, well, let's just constrain it and let's keep methane not going up, and you would still get some productivity gains, just not as high projected. So moving on to just and wrap highlights from the study. Potential productivity gains from this are significant with flow-on effects to profitability, where in some cases we're looking at doubling of profit. But the critical point in this is that no single technology can provide the transformational gains in productivity or profitability. The best gains come from combining a suite of technologies. Now, we showed the combination of 4 there, but even putting 2 or 3 together, additives there. But you do pretty well. Out of those 4, you probably get about 60% or so of what might be the additive gain there. There are regional differences. Interestingly, genetic gain and higher digestibility work everywhere, in all the regions, equally effective. Areas like from improving the nutrition, there was strong regional differences. For example, in southern Queensland, the region there is more productive, particularly through the winter months and dry season there, that we got less benefit from some of the nutritional strategies that, say, the northern herds and northern simulations. So I made during the talk there, small changes in digestibility can make very large differences to production. You can get significant benefits from modest genetic gains, particularly if growth, efficiency and fertility are combined, and increases in growth flow through to a whole range, and weaning rates. And I haven't touched too much on mortality and what I've explained. Mortality, in our sensitivity analysis that we did, profitability is very sensitive to mortality, and those production production technologies there also mortality by quite a bit. Old technologies, such as stylo, can have large impacts, and as we've seen in the work presented yesterday, that's important. Protein supplements, highly beneficial at low cost, and the impacts are also via some energy there. And irrigated forage can lead to some improvements, but there are some associated risks, and particularly around the things. So, in summary, there's some good potential to increase productivity and profitability that provides some directions to, because one of the main aims of this study was saying, well, where do you invest your effort in R&D in the future? It wasn't saying on this particular property you can achieve that, but a study to explore where future investment might go. But I think the big opportunity is to focus on putting in place a whole series of innovations that might be incremental individually, but together they lead to transformation. I'm going to leave, I might have used this example not here in this audience, but I'm just going to use the iPhone as the example of this. Together, we all mostly had mobile phones, and most of the mobile phones, apart from making calls on, which seems to be a secondary function, nearly all of you could connect to the internet and those sorts of, and all had different sort of added applications by the time the iPhone. What the iPhone did was put all those innovations together in a package that just made a huge difference and transformed the way that we look at that, and of course odds are now copying it. So I say that the challenge and the opportunity for the northern beef industry, can we create the iPhone for the northern beef industry and really get some productive gains and take us out of the sort of pretty dark places where some of the industry is at the moment. So I'll leave it there. Thanks.